Hi everyone, welcome to our video on supply and demand linear applications. So in the picture here, just have a small picture showing a supply curve and a demand curve. And so since ours are linear, they are forming lines. Now when you take like an economics class, or if you have to, sometimes they're not linear and they do have a more curve to it, but here we are looking at the nice linear case. And when we do have a linear case, our supply is the one that's going upward. Our demand is the one that's going downward. Where they intersect would be the equilibrium point. So that's what's ideal to have. Now, anything left of the equilibrium point, that would force the below is a shortage. Okay, so there's not enough supply, so the demand is too high, while everything above the equilibrium point would be a surplus. So there's too much supply and not enough demand. Okay, so in both cases, money's being lost for whoever. So they're looking to get that equilibrium point down. All right, so anyway, let's see how that works. So the way that they break these down, they also don't use X and Q, or X and Y. They usually use different letters, but that's okay. We don't always have to use X and Y in math. So let's show what they do in these scenarios. So in this example, it says, let the demand function for a stuffed toy be P equal D of Q equal 30 minus 2.5 Q, and the supply function for the stuffed toy be P equal S of Q equaled 1.5 Q, where P is the price in dollars and Q is the quantity demanded. So in this scenario, Q is kind of like the X, and notice it's where X would be if it was a normal function. And then the P is acting like the Y. Okay, so one other thing to note, let me highlight it. They're saying the quantity demanded should be in thousands. So we got to be careful of that. Okay, so in thousands, so it's not just a regular old number, it's thousands of numbers. Okay, so let's break these down. The main thing is just to make sure we've got the correct match. So for instance, I'm going to do demand in blue just to have it there. And then let's make sure we've got our supply is that one. Okay, so, and notice there are kind of three parts to it. The weird equals, that's okay. We'll still show how they want us to break it down. Okay, so in this problem, number one, they say find the price when the demand, so that means I want to deal with the demand function. So I've got my demand function, P equals D of Q equals 30 minus 2.5 Q. Okay, and they're saying Q is the quantity demanded, so we already have that marked, and then P will be the price. All right, so in this number one, they say find the price. So that means we're solving for P when the demand is 5. Notice they wrote the word 1,000. So in this problem, they do want us to use Q equals 5 because it's already in thousands of dollars. So this represents 5,000. Okay, it's because it's in thousands. So we want to keep it as just 5. Okay, and so they do want us to find the price. So the way that we want to break this down is we're just going to use P equals and kind of just skip over the middle one. And from there, we're going to sub in. Let me do it in highlighted pink. We're going to sub in 5 for that Q. So it'd be P equals 30 minus 2.5 times 5. Okay, so this middle portion is getting skipped out because we are looking for the price anyway, and they're saying the price is represented by this function notation. So it's just, again, a kind of strange way that they break these down. But at this point, if I am solving for P, well, we could do that with just order of operations. So we've got P is equal to 30, 2.5 times 5. Okay, so 2.5 times 5. I think that's 12.5. Let me make sure though. Okay, so we've got 12.5. So we have 30 minus 12.5, and then now from here we can subtract it. Since the decimal I don't like, I'm just going to really make sure. So 17.5. Okay, so we've got the price is 17.5, and they say that is in dollars. So let's go ahead and put our dollar. Okay, so if they say interpret this in words, what we've got is the price is $17.50 per toy when the demand is 5,000 toys. Okay, so that's what the price should be when the demand is 5,000. Okay, so they're just gonna show. So these functions are showing how to fluctuate the price when we have these different demands and different supplies. Okay, so often if there's a very high demand but like a low supply, then that price is going to be pretty high. Because, well, so many people want it, they're willing to pay extra even if it's not worth as much. So a real-life example of this, if you're curious, I don't know how dated this is, the Tickle Me Elmo. That, and it still goes on today, so like with shortages of, say, like, I don't know, like the PlayStation 5 right now, I think is one of those that's been since it came out. I'm not sure, I didn't keep up to date with it, but so that has a high demand, so it's hard to get. So often that price is higher than what it really is worth because these companies can make money when that demand is so high. Okay, so if you're curious about that, the Tickle Me Elmo, so it's just a stuffed toy that you could tickle and Elmo would laugh, but people were able to sell those things on like eBay for thousands of dollars. It was crazy. Okay, anyway, let's go back to what's really going on with this problem. Okay, so in number 2, it says find the quantity demanded. So it's back to still demand, so still in blue, when the price is $12. Okay, so they're saying the demand, so still use the demand, so I'm still using my blue. So P equals D of Q equals 30 minus 2.5Q. Okay, so the demand, so I'm pretty much just getting my equation set up based on the keyword. And then from here, let's break down the rest. So they're saying the price, so the price is $12. Okay, so find the quantity. So that means we are finding Q. So P equals 12, and then we want to find Q when that P equals 12. Okay, so kind of like the last problem, we're just going to say, well, this is where the price is 12, and then pretty much just skip over the middle portion so that we can have equal to 30 minus 2.5Q. So that's what we wanted to find. And then now it still is solve an equation. We just have a little bit different steps than what we had above. So in this one, we would subtract the 30 on over to both sides. So we'd have negative 18 equals negative 2.5Q. And then we would need to divide both sides by negative 2.5. I'm out of room. I'm going to verify, though. Notice the two negatives would become positive. So I am just going to do 18 divided by 2.5. And we get 7.2. Okay, so we've got Q equals 7.2. And remember, this is in thousands, so it might be worthwhile to just instantly put that word in, 7.2 thousand. Okay, so what this is saying is when the price is $12 per toy, the quantity demanded is 7.2 thousand toys. All right, there we are. Okay, so that it's just breaking it down. Okay, so again, it's just kind of just showing what they should do based on certain situations with these toys. Okay, so if they price it lower than what they did in the previous one, then they should have more ready to sell. Okay, so that way, they can try to make more money. All right, anyway, let's see what we've got for number 3. So number 3 says find the quantity supplied. Okay, so there's our key word, supplied, at the price of $10.50. So I want to use the supply function, which is given to us in the problem. They tell us it is P equals S of Q equals 1.5 Q. And be careful with Q. I try to make it so it has like the little curly tail so it doesn't look like 9, and also make sure to write it low. All right, so find the quantity supplied at the price. So they're telling us P equals 1050, and then we're going to find Q again. Find the quantity supplied. So supplied is our supply function. All right, so kind of like before, just making sure we're putting everything in the right spot. So they're saying just change this P into 1050. Again, kind of skip over the middle because we have multiple equals, and what's more important to us right now is the far right. So we have 1.5Q. And then from here, we could do the division, divide by 1.5. And we would get, again, I'm going to use my calculator just to be safe. So 1050 divided by 1.5 is 7. Okay, so we've got 7 equals Q. And again, that's in thousands. Okay, so let's just put it in words to the side here. Okay, so when the price is $10.50, the quantity supplied is 7,000 toys. There we go. Okay, so that's how we can interpret it. So just making sure, again, just putting the right numbers in the right spot. Okay, so let's continue with our number 4. So find the price when the supply is 8,000 toys. Okay, so find the price supply. All right, so they're telling us use the supply function again. So P equals S of Q equals 1.5Q. They're saying find the price. Okay, so that means we have P left blank for now. You can kind of skip over the middle. They're saying we have 8,000 toys. Okay, so be careful of this. So they're saying Q is 8,000, but be careful. Here's where we just want to change really into words, 8,000. So we should be just plugging in 8 because this is already in thousands. So we don't want to plug 8,000 into that Q, the whole 8,000. We just really want to plug in 8. Okay, so notice the change in words, and that's just all from right there in that small parenthesis. So we just want to catch it. So quantity is in thousands. So we want to change it to say 8 and then put the word thousand instead. Okay, kind of like how they did it for some of the first one. So the first one was 5,000. So we didn't want to do 5000. We really just want to do 5. Okay, so back to this one. Let's just plug in 1.5 times 8. And then from here, we could do that multiplication. I think it's 12, but let me verify. So 1.5 times 8. Yes, 12. So $12. Okay, so we're at $12. So this means, okay, so when the supply is 8,000, let's actually keep it in words. 8,000 toys. The price is $12. All right. Okay, so that's how we can find these different parts in these equations. So the main thing is just, so they have, so this is pretty rare in math where they have something equals and then another equals. But when they do, it is just picking apart what's really important with us. So kind of the middle portion is just letting you know demand, so D for demand. And same deal with the middle portion and the bottom two here. S is for supply, so just making sure we're catching those key vocabulary words. Okay, and then for number 5, they want us to graph both of these equations on the same axis and find the equilibrium quantity and the equilibrium price. All right, so let's break that down. Let's go ahead and set up a big axis over here. Okay, so typically we have the x and y axis. But with this problem, we didn't have x and y as our letters. Okay, so when we were breaking it down earlier, we were saying q is the quantity, and that's acting like the x. So this x is really, I'm just going to cross it out and say, really, it's kind of the q-axis now. And then the y-axis, it looks like that should be the price. Okay, so we've got, instead of y, it's the letter p. So we just make those quick adjustments right away. Okay, and then to graph these, well, let's go ahead and show each of those. Okay, so we have p equals, let me rewrite them. So we have p equals d of q, which equaled 30 minus 2.5 q. And then we had our, let me do this one. Actually, so I already wrote it in black ink, but let me put a star. That one will be in blue. And then to keep our colors, this one I'm going to do in purple or pink here. So we have our supply is the 1.5 q. Okay, and it really is very much, so both of these is very much just like, so it is graphing. It is very much like doing y equals 30 minus 2.5x, and it is just like graphing y equals, well, let me keep it in purple, did the same thing, y equals 1.5x. So it's very similar to that. Okay, and so what we can do, so, and we could use a calculator as well to verify, but I'm going to do the supply one first, so which is 1.5x. It has a 0 as an intercept. Okay, so let's break down. Let's break down. I'm trying to just figure out where to put it. Let's go ahead and show plus 0 to the side, and that way I can just say, well, our y-intercept is 0, 0, and then it has a slope of 1.5. Okay, so I'm not going to make this to scale, but I am going to, there's our y-intercept, and then it should, the positive slope means it should go upward. Okay, so something like that. Okay, so this is our supply. And we could write it as S of Q if we want to. Okay, so our other one, the other one in blue, now this is not set up in the exact form for graphing, but we can rearrange it. I notice I'm keeping X, and again, I'm just saying, well, X is pretty much Q in this problem, so that way we can treat it all the same way. Okay, and then with this problem, we do have the y-intercept is 0 and 30, and then it does go down, the slope is negative 2.5. Okay, so 0 and 30, I'm not sure where that is on the actual grid. Again, I'm just going to plot it, let's say about here should be fine. And then our slope is negative, and it would be steeper than the 1.5, so let's have it go a little sharper like that. Okay, and once it hits the axis, it would stop. I'm going to show an arrow, but it would end. Since it's a real-life application, these lines do not go on in both ways forever. Okay, so with that, though, we do have it, and let me label it. So this blue was the demand, and we have D of Q. Okay, well, the equilibrium price is where the two intersect. And so to figure out what their equilibrium price is, we just need to set the two equal to each other. So let's set, so because that's where the two lines are equal. So let's go ahead and set our two equations equal to each other. So equilibrium is when the D of Q equals the S of Q. Okay, and so we'll use, so it depends on what side we want to use to plug in. So the D of Q, let's go back to blue. So this D of Q, it'd be best to use the 30 minus 2.5Q and then set it equal to the S of Q portion that's on the right, the 1.5Q. And then now we just want to solve, so we can add the 2.5Q over So we'd have 30 is equal to 4q, and then we could divide by 4. So when we divide by 4, I'm a little out of room. I'm going to put it to the right for now. So 30 divided by 4 is 7.5. And actually, let me verify real quick. 30 divided by 4. 7.5. Okay, yeah. Okay, so 7.5. Okay, so that is our q. Remember, q represents the x. So for now, I'm going to write it as 7.5, comma. And then let's get our y-coordinate, which again in this problem is really a p value. And to get it is, well, I can just plug it in to either of those equations. Okay, so for p, we're going to plug q equals 7.5 into either one. So into d of q or s of q. It should give us the same answer. Okay, and so let's plug it into s of q since it's a little faster. Remember, this is representing a price. So we're going to plug in 7.5, and we'll have 1.5 times 7.5. That one I can't do mentally. Let's get it over here. 1.5 times 7.5, 11.25. And that would be a dollar amount. So I'm going to cloud that. So that is our price equal to that dollar amount. That is our Q. That would be in thousands, so 7.5 thousand. And then I'm going to still label it 11.25 right there. Okay, and so we have our answer. So I kind of took up a lot of space, but they said find the equilibrium quantity. So the equilibrium quantity, I'm going to squeeze it in. So sorry about this. Equilibrium quantity is 7.5 thousand toys. And then the equilibrium price, let's just say with an equilibrium price of that 11.25. Okay, so sorry it's not in the most room. I'm just trying to bold that out a little bit. Okay, so that is our equilibrium point. So the 7.5 is the quantity, the 11.25 is the price. I did say you could try both equations. Let's just verify real quick. So if I do plug in 7.5 into the quantity equation, I would have 30 minus 2.5 times 7.5. And we get 11.25 as well. So it should that's a way to check your answer. So that's it says into either one of them. But if you do them both, it should give you the same answer. So that way you know if you're right or wrong. Okay, so that's it though. All right, so we found the equilibrium. We're finally done. All right, well, if you do have questions, please let me know. Otherwise, thanks for watching, and I'll see you again soon.